perform complex analytical um, tasks that you have in SQL. Like unlike the regular aggregate function, when we work on our aggregate function, the Windows function always operate over a specific range of roles that are related to the current roles that we are trying to find. Another key thing that we need to understand about the Windows function is that we can do an aggregate function without calling the group by on a regular aggregate function. We can do an aggregate function without calling a group by, and also in the Windows function, the key thing about Windows function is that we need to always supply a clause that is called over, and that is part of the syntax. Now, the key characteristics, of when we work on a Windows function is that we need to ensure that on the over by clause, we can call a partition where we can partition the query by specific columns. We can do an order by in the over clause, and we can also sometimes put a Windows framing on the query. So what we will be doing today in our aggregate in our Windows function, we'll be looking at a roll number, we'll be looking at rank and dancing, we'll be looking at lagging. And at the end of the day, we'll be looking at, I think we could probably start with the average and count and every other regular aggregate functions that we know. But before we jump into SQL, the key thing to understand that use cases, or when do I use a Windows function, could be a situation where I'm trying to identify the top or bottom performers within a particular group of record, or my goal is to calculate any moving average over a specific range of time, or I am interested in assigning ranks, calculate percentiles, or even identify any percentiles in my result subset. Or I want to compare the current value and the preceding value of a given range of data set. Another thing I can do with the Windows function is that I can calculate an accumulated total. So basically, if me as a customer, right? If me as a customer, I have spent up to a certain amount of dollars, I can be interested to put, if I spend a specific amount of dollars within a specific range, say like 10, 20 times, those incremental of my expenses or the number of my expenses, the Windows function can show me all those expenses, and I can be able to navigate and understand what I spent in a specific period of time. The benefits of using a Windows function is that it is flexible, it is efficient, it is easy to read, it is scalable, and once again, it is fun. So what we're going to do, we're going to jump in SQL and begin to understand what exactly our Windows function looks like. So here I am in SQL. The first thing I want to do is to specify the database that I want to use. So I want to use the Paulins Data Tech. Let's say go. And I'm going to run this code and verify. It tells me that yes, I am now tied or hooked up into the Paulins Data Tech. Now, from this point, I want to start understanding what do I have. So the table that I'm going to focus on, because it has all the flavors that we need, I'm going to focus on the table called billing, because there we can get some good information of what we're looking for. So if I write a query that looks like this, select star from dbo.billing, And if I run this code, I can see the information in the billings table. But what I want to get from here is that I want to zoom in into only pulling out the patient ID, the bill date, and the bill amount. That is the three columns that we'll be working with to understand our Windows function. So what did I say again? Patient ID, and I need the bill date, and I also need the bill amount. And if I run this code, bill amount, bill underscore amount. So if I run this code now, I can see that on this date, the patient ID 1 was billed for $250. Patient ID 2 on this date was billed for $150. So that's good. So now let me say if I want to do a regular aggregate function of the sum of bill amount per each one of these guys, the patient ID. So I'll say I'm trying to do a regular aggregate function. So that means I can come down here, I can put, I say sum, I'll call the sum of the bill amount. So I can call this the bill amount. And I'll give this guy an alias, call it AS. AS. And I can call this guy total bill. Maybe we'll call it total bill. And if I run this code like this code is wrong, because when I run it, it's going to fail, telling me that one of the information is wrong, which means I need to supply a group by for this rest of for these other ones that is not part of the aggregate function. So to do that, I can come down, I say group by. Group by what? Patient ID, comma, I'm going to put the bill date, comma, and I'm going to put the bill amount. The reason is because with the regular aggregate function, when we have an aggregate function and we have other columns that are not part of an aggregate function, those columns that are not part of an aggregate functions like this guy, they need to be in a group by. So if I run this code now, everything is good and dandy. So this patient ID 1, patient ID 1 on 3 different occasions, on the 11th, on the 12th, and on the 11th, and on the 1st of November, 11th of December, 31st of December, they spend different amount. And at the end of the day, this is the total that is just sum out to return. So it is still returning the same exact amount, right? So now let's see how we do this if we have to run it with a group by, with a Windows function. So if I come down here, say Windows. So I want to do the same thing using a Windows function. So like I said on the introduction video, a Windows function is always indicated by a keyword called group by. Sorry, over, not group by, over. So if I write this same code, so what I'm going to do, I'm going to borrow this part of the code and place it here. If I take this, so if I have this guy the way it is here without any problem, if I have this guy the way it is on here, and I leave it the way it is, but before the AS and after the aggregate function that I have, if I supply something called over, open and close the parentheses and put a space, this is a valid code, and this is what makes the the query or this particular code a Windows function because of this keyword called over. Now remember, when I wrote the code earlier without a group by for these people like this, the code failed, telling me that I need to supply a group by. Let's see if it will be the same thing in here. So if I run this guy, it did not fail, it ran. But the problem is that this over, if I have the code like this with just over, with nothing attached to it, what I am doing is that I am summing the entire bill amount for the entire record set. So for the entire record set, I am billing, the bill amount is 26,000 plus for the whole record. So general total. But now, if I want to get the result of how much does this, how much does patient ID number one actually paid, I have to partition the record. So that is where something called partition come into play. So this guy now is for everybody, but we don't want it to calculate it for everybody. We want it to only specify it by the patient's ID, individual patient's ID. So I can come down here and do this and say, I can put something that said adding a partition by. So if I paste, oh, yeah, I have the code. If I paste the code now, all I need to do inside of the overby, because if I leave the overby blank without supplying an argument, it is going to sum the whole thing. But if I put something called partition by, I want to partition the record by the patient ID, by the patient underscore ID. And I will put an order by. Order by, I can order by the bill date so that it will be easier to follow. I'll order it by the bill date. Let me arrange this code so that it is easy to read. Maybe bring this guy a little bit down here and put it like this. But if it confuses, I'll just put it straight like this. Now see the magic of what happens. If I run this code now, I can see what really happened. Pay attention to the result set. I will take this number one, for example. Let me go back to the prior result that we wrote. If I run this code like this, it says patient ID number one on the 1st of November spent $250. Patient ID number one again on the 11th of December spent $520. And patient ID, patient number one on the 31st of December spent $310. It is not summing it actually. It left it like that because of the bill date were different. So we did not change it. Now pay attention to our result for this one that we partitioned it by the patient ID. So pay attention. I'll zoom in into this guy like this. The bill amount for the 1st of November is $250. Then on the 2nd of, on the 11th of December was $520. 520 plus 250 give us $770. This is our calculation. Now, on the 31st of December, they spent $310. $310 plus 250 plus 520 give us $1,080. So you can see how it is giving us in details what is going on in our result set. So that is one power that Windows function can come with, and the flexibility that Windows function give us in our record. So just look, right, if you write this code, just read through this code. I did a sum over by calling the Windows function, and I partitioned the summation by the patient ID, and that is why it gives me each individual patient ID, because I ordered it by their date. Then at the end of the day, if you look at the result set, it is summing it and giving us the last record as the final result. So that is how we can use the Windows function to bypass the flexibility, this restriction that the regular aggregate function can give to us. So the next Windows function that I am going to talk about is the ranking. That's called ranking function. Maybe I call it ranking Windows functions. So with the ranking function, we can rank things accordingly and extract the informations that are needed. So this is how the ranking works. So I'm going to borrow this code. Oh, shoot. I'm going to borrow this code and place this code here, but I don't need the aggregate function. So I can take off the sum that we have because we don't need it. Then we're going to jump into the ranking and see what the ranking can do for us. So watch what happens. If I come down here, the first ranking that I want to write a roll number. A roll number that will count the rows of this record all over again. So for example, if I do roll underscore number, underscore number, and I'm going to open and close the parenthesis. And remember, this is the Windows function. For me to confirm that this is the Windows function, I supply a keyword called over and open and close. When I do that, I can come down here, the same thing, I can now partition it. Partition by the patient ID, patient underscore ID, and I am going to order by the bill underscore amount. Oops. Amount. And I'm going to call this guy. Yep, I forgot my by, so I'm good. That's fine. I'm going to call this guy roll number. Oh, yeah, roll number. And I missed my by, so I'm going to put the by here, and that's it. And if I run this code now, watch what happens. I have a column that is counting each patient ID because I am partitioning it by patient ID, right? So now it counts that is 1, 2, and 3 patient ID. And see an interesting one. The 2 is up to 4. And what did it count? It said 1, 2, 3, and 4. So take, for example, I am interested in maybe my boss wanted me to only extract the last amount of the last billing that was sent out. Maybe there was an error. Let's just use a word like that. Maybe there is an error for the bill amount that is sent out to the clients or to the customers or to the patients. So we want to make sure we retrieve those billed amount, or we want to make sure we view those bill amount to see them. Without the roll number, it could be hard on how we can extract it. But now with this, we can only target this code We can target this code only where the roll number is the highest one. Maybe we just say the highest roll number. So every single time it will return the very last roll number that we got, because why, we ordered it by the order ID. Sorry, by the bill amount in the ascending order. Or we can say either way we want to do, but we have an idea that we can use to target the bill amount. Or if we say we change this and say, let's do by bill date, and if we run this guy, now we have it that the bill date is always the highest roll number, because we are partitioning it we are ordering it by the bill date. So if you look at number 2, for example, that has 4, right? We have the first one is 2nd of November. The second one is 12th of December. The third one is the 1st of January 2023, and the third one is the 11th. So the last one of the roll number is always the last thing that I need. So I can add another rank function. I can add another rank function called rank. It is called rank, and I can open and close the parentheses, and I'll call over. My over that I call open and close, I will come down on this over. I can order by the bill date. So I say bill date, bill amount. Oops, the bill amount, and it doesn't matter descending or non-descending, but we've used ascending a little bit. Let's change it to descending. So I can call this guy and say this guy is the rank function. And if I run this guy, I can see this is what it is doing. This is the roll number. This is the roll number, and this is the ranking. And let me see where number 1 is. You know what? Let's just how does the ascending looks like? Let's see what ascending looks like. See if we can look at the data that way. All right, look at. So the roll number, patient ID 1. You know what? So let's order the whole record. I like to validate the record this time I'm running. So let's do order by patient ID. See if it's going to resort the data. So if I come down here and I run this guy like this, perfect. Now watch what happens. The roll number give it to me as 1, 2, and 3, no problem. But now the ranking of how this value 250 is ranked in the entire result set is saying it is ranked as 16. It said 150 is ranked as number 1 in terms of the ranking because of the ascending. So, but if we do the descending order and come back and check it, we can see that number 1 is being ranked as number 12. So that is what the ranking is doing. And the ranking most time is a little bit confusing to follow. So, but basically what it is doing, it is looking based on what we have on our over clause and ranking the values accordingly. Another one of the Windows function that we can look at is called offset. Oops. Offset Windows function. The offset windows function, we can get something like a lead and lag, or first value and last value. So we can get things like that and see how they play out in our result set. So for example, if I come down here, I'll borrow this code again because we're focusing on this particular thing. And again, remember, you can use this, these things can work in any result set that we want to get. So I'm going to borrow this guy, but take this other one off. I will come down here. The first one I will call is the lag. I open and I close the lag, and I close the parentheses. The lag of what? I am looking for the lag of the bill amount because I wanted to validate what the lag is. As a bill amount. And when I come down here, I want to partition it. But this time, I want to also check the provider that is billing this amount, that is billing this patient. So we can go to the provider, check on the provider a little bit. Then I can come down here now. I say I want to partition, oh no, outside of it, not inside. Outside of it, and I call my over clause, and I will open and close the parentheses, and inside of it, I will call the partition by. I want to partition by the patient ID, as we've been doing, patient ID, and I want to order it by the bill date and the provider that billed that particular provider that billed that particular patient. Maybe we can call this guy, so that is lag, right? We can call it previous value, something like that. Let me close this guy so that we can see. All right, let's see what is the problem here. We're having, it said the provider is invalid. Why are you invalid? Let's see. We have, oh, bill amount, sorry, I didn't spell this bill amount correctly. Let's see if that works. Okay, provider is still having problem. We didn't spell, oh, it is called provider ID. Now we should be good. Provider ID. And if I run this code now, let's take a look at something. Provider, where is he at? No, provider ID, not provider. We don't have anything called provider. We have provider ID. So now if I run it, I can see an interesting thing. It says the roll number confirmed that provider ID number 1 charge is the patient or work with the patient ID number 1. The bill amount for the first time the patient was billed was $250. There is no previous, so there is no amount. It did not return it. But while we are here on the second date, the previous amount is $250, and they captured it here. We come down to the third one. The last payment is $310, but the previous amount is $250, $520, and that is what it captured here. That is what the lag can do for us. There is another one called lead. So we can call lead. I will open and close the parentheses. Lead bill amount. Lead bill amount. I call my over. I want to over and partition the same thing so I can carry it, if I can borrow this guy rather than typing it and getting you bored. I can copy this guy and paste it here. And I can call this guy, maybe say next value. And if I run this guy now, look at that. Now, the previous, there is nothing after this guy. But for the next value that is ordered, or the next value that is on the list is 520, and they captured it. Now, when I am here, the bill amount, when I am on this stage, which is the 11th of December, I was billed 250. Sorry, 520. But what was billed before is 250, and they captured it here. And while I am here, what is the next thing that was billed? So the next thing that is billed is when I am here, right? And while I am here, I was billed 310. The previous thing that I was billed is 520, but there is nothing next to build, and that is how the lag work. The lead and the lag work. It will bring you the previous and the next value of the result set. So see another cool thing. Another one. See another cool thing. I can come down here. If I write select, so I want to write this one is for the first, first value, and it's called first value and last value, I believe. Last value. So see cool stuff. Very cool stuff. So if I borrow this code I'll take some stuff off. If I borrow this code and place this code right here and take these other guys off, and I come down here, there is something called first value. And if I open and close a parenthesis, I want to check the first value of the bill amount. And I can borrow the same partition or the overbuy clause, and I can place it right here. If, okay, I forgot the parenthesis. And let me say at this point, I just give it a, let me give it a value. Let me give it this and I say first value. If I run this code now, for example, see what it says. What is the first bill amount that was billed for this person? It is 250, and that is correct. What was the first value that was billed for number 2? It is 150, and that is it. With this, I can put another value, another function called last value. So basically what it is doing, it is going into the code based on my partition, returning the result per the name. You can see the answer is in the name. So I can put, maybe I can still do the same one. I just do it. All I just need to do is to change the information that says this one now is last underscore value. I do this, and I can call this guy last value. Oops. Last value. So let's see how the result be. Oh no, why am I still putting this? It doesn't matter. Remember, this guy doesn't matter. I can take it off, but I just wanted to see something in a well-organized way. So now let's take a look at the last value, how it behaves. Last value really doesn't give us any flavor that can really tell us anything serious. It looks like it is repeating the same result set every single time, which makes sense because at this point in time, the last value that was charged is 250. At this point in time, the last value that was charged is 520. At this point, on this date, the last amount, except on this date, the 31st of December, they bill this patient twice. Then this last value will return the last amount that was billed. But as it is now, it is only one date, one billing, so it returns that value together. And this is what the Windows function can do for you. It is a very powerful function. And with this, we've come to the end of this particular series for SQL for data analysis. And we'll be looking to bring in a different new series. I am thinking, I don't know at the top of my head, if you guys can help me, that would be very helpful. Maybe we can do Excel for data analysis series, Python series, or even advanced SQL where we can begin to build, create table, modify data like delete, update, and insert. We'll work with temp table, we'll work with derive tables, we'll work with stored procedures, write variables, and then, or we can build an SSIS series. It depends. I don't know. I can go either way. We can do Python series, go all the way to build visualization with Matplotlib, and maybe dive into machine learning and all this stuff. So I don't know. Whatever, if you guys can help me decide, but by next week, we could probably start a new series, which if I don't hear anything, maybe I might just take the SQL a little bit, but it's going to be an advanced SQL for developers or advanced SQL for data analysts. Other than that, thank you so much for sticking around. Thank you for the subscription. Please encourage the channel and let's together build a network. And I'll be coming up with a new series. I'll post it. I'll send out a video. You will see it. Whichever one that I decide if I don't hear feedback from people. Thank you so very much. And I want to take this time to wish everybody a happy 2024. Thank you and goodbye.